everyone, and welcome to the latest installment of Python Live, powered by Amicus Recruitment and the Live series. For those of you who don't know who Amicus are, we are a specialist IT recruitment agency that cover 5 key areas, including Python, Golang, Rust, JavaScript, and machine learning. I'm your host, Jordan Hayward, and today I'm joined by Richard Everts, who will be presenting on the art of synthetic data. Now, Richard has a brilliant background across software engineering, and in recent years has had a solid focus across the AI and ML space. We've been a bit back and forth with getting this one booked in, mainly due to myself and time frames and stuff, but really excited that we've got it scheduled in this evening, and I know it's going to be a great talk. So I'm going to hand over to you, Richard. How are you today?
I'm doing great.
Good to hear. Good to hear. Well, I'll let you take the floor, and then feel free to let me know if you need anything.
Awesome. Thank you, Jordan.
Nice one.
All right. So let me start sharing my screen in a second here. I'll bring up my stuff. Hope everybody's having a good day. I know it's Wednesday in the middle of July, so it's a hot one out there. Can everybody see my slideshow? Looks like it. Awesome.
Yeah, looks good.
All right. So real quick, my name is Richard Everts. I am the co-founder and chief product lead over at BestieBot. We're a home AI platform, and we do a lot of work specifically targeting Alzheimer's and dementia right now. We have some grants for that, and our work focuses primarily on camera hardware and custom AI networks. And we are very heavy in Python, JavaScript, and a little bit of Rust now as well. And so I was really excited to kind of talk about this because we've looked at how to create these custom data sets for some of the work that we're doing. And there are certain things that we can use Unity for. Some of it we can, some of it we can't due to licensing. But I did want to show everyone kind of the whole kit and caboodle about how this process works and how you can use it in your work and your projects. I don't get paid anything from Unity for this. This is actually me just doing it on my own. So I hope that you get something out of it. So let's hop in real quick. So synthetic data, what is it and why are we using it? So we know today there's a lot of synthetic data out there, things with like Stable Diffusion, Midjourney, that's kind of like the imaging. Text, everyone knows about ChatGPT, Bard, Claude. Llama 2 was just released yesterday, I believe, or today. Audio, 11 Labs and Fast Speech, these are places that you can send off your audio and get something to come back that replicates somebody's voice. And there's also some ways to create synthetic tabular data. And all these tools are great. And there's a kind of an explosion going on right now. But today we're just going to focus on images. And instead of using DALL-E and Stable Diffusion and Midjourney, we're going to take a look at one of our tools, which is the Unity system. So for example, here, we have these individuals. This is a website you can go to that says thispersondoesnotexist.com. And on this website, it shows you pictures of people that don't exist at all. And so really there's no proprietary need. There's no licensing challenges here with using the data. And because of the way we train a lot of our neural networks right now, they're very data hungry. And so these synthetic data points really are helpful. Now, things are starting to move into 3D simulation. And there's a reason for that. You probably are very aware of Apple's new move with their spatial audio tools. And a lot of the AI systems are moving into that 3D spatial realm for AI. I truly believe in 3 years, everything's going to be 3D driven anyway. And the question is, how do we create some of the data for this? And so here's the example, some of the examples out there. Facebook's created a lot of this, Tesla, and a lot of companies are generating synthetic data through these tools. So for instance, in the upper right-hand corner here, you see that we have Unity. These are some of the examples of people, which we're going to talk about today. Down here, you see some cars and some of your KUKA robots and all the indoors. And then here you have like retail stuff. These are all synthetically generated, except for this right here. But what ends up happening is that you get a digital twinning of the actual 3D environment, and then operations happen on the 3D environment. And so that's kind of what we're talking about today, things moving to replication in the 3D world. And so the Unity tool set has a basic idea, and that is we take, let's see if we can start this video here. It's kind of an animated GIF. There we go. Or GIF, depending on how you pronounce it. But you have a background, and it's just some random background. It doesn't have to make sense of any kind. And then what we do is we isolate the particular objects that we're looking for, and we either do things like bounding boxes, which many of you are familiar with if you do custom data computer vision work, instance segmentations. We have key point detections here. And notice the backgrounds are just weird, like they don't match at all. And in fact, that's a lot of what happens here, because they want the systems to be able to pick out in the midst of a noisy background their particular objects. And so this is very similar to what you're going to see tonight with a lot of the various setups here. And so let me see, it's going to start repeating here in a little bit, but I think everybody kind of gets the idea about how you have foreground items and background items and how they really don't match. All right. So let's take a look at, well, how does it perform? That's a big question here. So precision and recall, I think most people here are probably pretty familiar if you have a Python background what those are. Usually you have one goes up and the other goes down, and it's kind of a balancing act where you keep your true positives, your false positives, and your false negatives and true negatives. Kind of, you try to keep it in line. So you don't want to make the system too sensitive to your particular object, because it might label too many things as your object. Likewise, you don't want to lower the threshold, because then it might name too many things that aren't your object. And so it's that balancing act of finding that proper precision and recall. And what, in this particular example, I'm going to give you some numbers about the performance here. So Cocoa dataset is a dataset that has a lot of images of people in it. It's very common to be used to train, especially on key point detection. It has 17 key points that you can use in your key point detection models. And it's kind of an industry standard to test a lot of computer vision models. And the PeopleSans people, this is Unity's binary that they use to train. So this is simulated data. So in this example that we're going to look at for the data, they had 64,000 items in their training set for Cocoa, almost 3,000 validation for a total of 262,000 instances, 149,000 with key points. And with PeopleSans people, they added all these various levels. So you have about 2.9 million extra images that get added to this data set. And as we know, the more data that we add to these systems, the better that they train. And that bears it out here. So this is an example of what kind of results. So if you have, I know it's a little hard to read because you got a lot of different rows and stuff, but we have this row, or excuse me, column, size of real data. So if your size of your real data is 641, and you train this bounding box, you train this model and you judge it by the bounding box AP, from scratch, you get a 13%. If you use ImageNet, 27. Now, if you use PeopleSans people, you get 42.58 in terms of your accuracy here. And so you can see that based upon just training it from scratch, that's a 28% increase. And the delta for over ImageNet, so if you trained it with ImageNet by adding the PeopleSans people, you get 14%. So if you're training a custom data set, right? So you have a specific items that maybe you only have 10 or 15. So, you know, many years ago, when I set up some of my first data sets, I was looking at, I wanted a predictor for Jack Skellington from The Nightmare Before Christmas. I wanted to just use a tool that could pick Jack Skellington out of all these different setups. And I could only find maybe 50 to 100 pictures of Jack Skellington that were really set up properly for a computer vision task. And so if I had created a simulation of Jack Skellington and printed out another 100,000 images, my model would have been fantastic. right? And so that's what you see here is as the size of the real data increases. So if we go up to 64,000 real images and we add, a couple million of the PeopleSans people, we're only getting about a 1, maybe 2% difference. Especially, we look at key points, you're looking at maybe a 2% difference once you have a lot of real images. So it's really helpful when you got to fill in for small data sets, when you don't have 60,000 images already prepped. Okay. And so that's where it really comes in. I've seen companies use this. I can't give the exact details here, but I can let you know that there was a company that I spoke with where they needed to do a live horse race, and they needed to be able to look at the horses on live TV and perform AI in real time on those things, and add like the little traveling data that follows the horse around, like who the jockey is, recent stats, et cetera, et cetera. And so in order to do that, they could not train it on live pictures. They actually had to create it all in simulation to run that. And it worked perfect. It worked perfect. They put all the horses in the simulation with their numbers. They printed out 20,000 images of each horse in I think it was Unity at that time, and they were able to get this to work. So it does solve problems. All right. So that's it for the background. And I really want to take more time getting through the demos and answering questions. Maybe we stop here real quick, Jordan, if there's any questions that we might have before we dive into the demos.
We don't at the moment.
Okay.
So yeah, feel free to jump straight into the demos.
Awesome. So let's take a look at doing this in Python real quick, some of this stuff. So if people have created data sets in Python, they know this can be a challenge. And you're probably very familiar with these kind of files. So I've produced dozens of these now, and they get easier over time, but you're always referring back to things. So what I have here is an image. This is actually from our office here. And yes, those are Christmas trees in the background. No, I know it's not Christmas time, but we leave them up all year. But it's a lot of fun. Here, this is me. And what I did was I needed to do key point detection. And so in order to do that, I have a data set, right, which is a JSON object. Everyone here is probably used to working with JSON objects in their Python work or JavaScript work. And it has a bunch of key points and a bunch of different values in it. Now, this one, you see this 32, 33, 34, that's actually pulled from this. This is the image here, the raw image. And here's the depth map. Depth map is a stereo disparity, right, between the two different cameras. So you can get an approximate depth ranged from the camera to the particular object. And this is very common for depth maps. As you can see here, it matches up pretty good. You can see the couch. You really can't see much in the back because outside that range, you really can't see it. But you can see the person over here. And so what ended up happening was I actually had to go in and using OpenCV, go in and calculate approximately what these values are based upon this image. And I averaged out like a circular amount around the key point. So maybe like the 9 pixels around the key point, just average the values to get a distance. It was accurate sometimes, usually not in this particular instance to create this custom data set. And so what I had to do instead was I had to manually do this and pick out numbers. And so for 1,000 images, it took me almost a full day of work. And so you can imagine if I needed 40,000 images, that would have been 40 days of work. And so a lot of us who are building these things in Python, and it's very simple here. So we open a JSON, we get our image name, we get all the values, and then we plot our skeleton. Right, so we iterate over our skeleton knowing that these are the approximate list values, and then we just create lines between the key points and map them out. It makes sense that once you've seen this enough, and then we print the image here. So the problem is that it just takes forever, right? It just takes a long time to do it. So let's look at, let's see here, Unity. Okay, so for people who aren't used to using Unity, it is kind of like an IDE for the 3D world. Again, I really believe that the 3D environments are where AI and machine learning are going in the next 2 to 4 years. So you got to kind of probably learn this stuff if you are going in that path, right? If you want to go in there, especially like AI agents and all that stuff. So over here is where you have kind of your hierarchy with the things that live inside your 3D world. And on the right-hand side, you have your inspector, which gives you information, okay? So let's look at our main camera. Every scene has a camera. And the camera here was created by Unity. So this is a custom script. And what happens is you can create these custom scripts and then attach them to objects in the 3D world. So if I have a sphere, I can attach a script to it, which says, this is a ball and it moves this way and approximately has these values, right? If somebody hits the ball, it does this, right? So you can attach these scripts and all these things are described in the scripts. So it has an ID, description, right? So these are all things that happen because of this script that you attach. And so that's kind of how customization works. Now, I know it's in C#, which is not something that people here are used to using probably. But for this, I didn't have to write a single line of C# code. I could and dive in. That's where ChatGPT comes in for everybody here, I'm sure. But what we have here is we have this camera. And under here in this camera labeler section, these are the things where they're built by Unity already. And they allow you to add different kinds of labelers to your system. So if you need a bounding box labeler, a depth labeler, which we'll be using later, key points, metadata, you need to do object counts, occlusion, the instance segmentation. Again, these are all the things that you can add that are already pre-built. And you can add your own. So if you needed a specific kind of LiDAR, for your robotics work, you could create a LiDAR labeler, however that works, right? So all these use a perception label ID config. It's just a configuration where it has a list of all the labels we're going to use. So when you do normal object detection, right, Coco data set has what, 80 labels, something like that. So, this is where things like ID, airplane, human, cat, like all those things have an ID label. Well, we set that ID label here. And in this example, we're going to use for a retail group, we're going to use like cereal, whipping cream sauce, the Barilla pasta containers. So we're going to use those as kind of our things that we're going to use bounding boxes on. We're going to keep track of the counts, and we're going to do an instance segmentation on these things. Okay. Now, that's the first thing. That's how we set up the data we're going to get from this. Now, the simulation scenario is kind of like the main function, right? And so in Python, you have a main function. And so in that function is where you do a lot of your actions. Well, that's kind of what simulation scenario is. It's your main function. And we have these things called randomizers, but it's poor language. They're not really randomizers. What they are hooks that you can do any kind of function with. You can do anything you want with them. So if you need a hook of some kind to create some kind of function, this is where you would do it. And so what we're going to take a look at, there's a bunch of them here. You can add and search for many of them. We're going to look through a couple of them today. So we have background objects, textures, hues, and rotation. We're going to turn off the foreground. So we set these up. We have a background object, right? So these are things that are going to live in our background. And we're going to add textures. These are all the random textures that we added, like avocados, kiwis, limes. They're just random things that we put in there. And I'll show you what it looks like and why we're doing this. And then a hue offset randomizer to change the color of things, right? So let's take a look here. Actually, I got to get this out of the way here. There we go. All right. So let's take a look at what we'll see here when we run this. We should just see a background of a bunch of crazy colors. It does take a little bit. There we go. So it's going to go through them real quick. And all right. So You may be wondering what this is. Remember, this is that crazy background that we have on all the pictures. And then we're going to put things in the foreground so our system learns to pull things out of these crazy backgrounds. So it's just a random background. That's all we're creating. That's all we're doing. Now, what are we searching for? Well, in this particular instance, we're going to place things in the foreground. So these are the items that we're looking at. And I'm just going to double click so you can see them. So for instance, this is a candy lind. Okay. And what this is an object. It's just basically a rectangle. You can see it here. It's just a rectangle. And if you haven't worked in the 3D world, really what these things are, let's see if we can find the element here. This is the material. And let's look at it. And I'm on Linux, so of course I'm going to use these weird programs to open things. So this is the material that gets added onto the thing. If you're not familiar with the 3D world, you kind of probably need to learn how these things work a little bit. But essentially what you have is you have a shape, right, which is that thin rectangle, and that has what's known as geometry on it. And so those are little triangles usually, or rectangles, that are organized in a way that are efficiently rendered by your system. And that's where your tools like Metal or Vulkan or CUDA Core, like these different are DirectX, where they create these geometries really fast so you can play games and do things in the 3D world. And then you have these things here, which are really just images which get wrapped around the geometry. And so the images will get divvied up in particular ways to wrap properly, okay? And it's called UV mapping and wrapping. And so that's how we get this onto this, right? It's just done with our 3D libraries that are built into our operating systems. Okay. That's just a little background on 3D work. But what you have here in the simulation scenario now, I'm going to turn this on and let's see what we get now. Okay, now you see our bounding boxes and our instance segmentation is going to go pretty fast here in a second. I mean, you can hear might be able to hear my laptop start to take off a little bit here because I got huge fans working on the 2090 that's in there. But okay, so we created all those things. Now what? Okay, now it gets where it gets interesting. So let's show our folder here. So we have solo 1 because it tells me where it put it. And let's take a look. Well, let's pick something up here. Okay, so that's our image without any kind of recognition. There's our little lint thing right here at the top. Awesome. So we'll have that. Looks like we have a Cheerios box in the foreground, some milk, some other things of cereal. Okay, great. Here's the instance segmentation of the things that we identified, right? So this has already been created for us, an image with it. And then this is our data. Now, let me close this real quick. What you end up having here, in this particular image, you have the different ID labels. So many of you who work in these fields will probably be familiar where this is our categories. These are the ID labels. How many of them are in there? Categories. This is a color. So this is our instance segmentation information. Let's see if we can find bounding box. There it is, bounding box. So this is kind of like bounding box information. And it gives you an origin and dimension. Now, you may be looking at that and saying, this doesn't look like any kind of normal AI information I'm used to reading. And you would be right, because why would Unity use something that everybody else uses, right? So what they did was they created a tool to convert this. This is known as a Pi Solo format. Now, there is a reason that they did it, and I won't go into it too much, but there is a Pi Solo format which you can use to convert all of your information from the Pi Solo format to Cocoa or YOLO, the two big ones. Okay, so let's take a look at what we got here. So I'm working in my own environment, the Unity environment, because you have to install some stuff for Pi Solo. So you probably want to work in a virtual environment for this, like a Python virtual environment. So let's see here. So it is Solo to Cocoa is the format. Okay. That's the command. So I'm going to convert this to Cocoa. It's Solo 1, and I'm just going to call it Solo 1 Cocoa. And that's it. It's just a quick conversion here. Okay. Let's log in to see what we get. All right, so we have our conversion. And if you're used to Cocoa, this is what you're going to get. So I have my camera images. There's our camera images. And then everything's in one file. This is the bounding box. Now, this is probably more of what you're used to seeing, right? So you have your categories. They're going to be, let's see, they're usually here at the bottom. Yep. So an ID and your name, whatever it is. So there's our lint one. It's ID 6. And then up here, you're going to get your bounding box information for each picture. So it'll tell you, okay, this has a particular image ID of 19, right? So it knows which image it's talking about, and it'll give you your bounding box data, which is usually your upper left-hand corner and lower right-hand corner, right? That's how you get bounding box data. And it's exactly like you get out of Cocoa. And so this is all set up for Cocoa data. So you could dump this right into your training. You just have to figure out how to munge the data a little bit. But that's it. So then when I go in here and I look at this, I realize, holy crap, I just made 100 images and was able to label all of them like that. I could have just as easily turned this up using, if I go back here to Unity, I could have gone into my situation, my scenario. Instead of doing 100, I could have done 10,000. It would have taken me a little longer to wait for them to be done, but I could have had 10,000 images. I use this to, test out. I use this particular thing to test out an idea, and with 100,000 images, it took most of the night to create. But after that, it was all labeled and ready to go, and I just dumped it into some code that I had generated off of, sad to say, ChatGPT code interpreter. And I was able to test it out pretty quick in one night, an entire idea, which is pretty amazing. Now, that is a little bit about this kind of placement with using PeopleSans and everything like that. That's for any kind of custom data set. Here we use it for a retail setting, but you could use it for anything that you need to add to, your particular data sets. So I have 2 more demos quick on humans, but I just want to stop real quick just to see if there's anything, Jordan.
Yeah, we do have one question from Chuck Durham. He's put, okay, so this is using 3D objects and images for auto labeling and building output to run the training.
That is correct, yes.
Yep. Perfect. That's pretty much it. Other than we've had one other comment saying Christmas is every day. So
that's right. Office. My people, I love you out there.
There we
go.
All right. Perfect.
All right. So, okay. So let's take a look at a second piece here. Okay. Just waiting for this. Okay, there it is. So now we're moving on to doing this with humans. Now, one thing I want to mention about this is a non-commercial license, okay, for humans. So if you're going to do stuff with synthetic humans, you can't use this. All right. So here's what we have. We added a perception camera. So we added a camera again to this. And these are the things that I chose for this time. Instance segmentation. Now I'm doing key points. Key point labeler. Key point 3D labeler. A depth labeler. Oh, I disabled that for this one. But you could add a depth labeler and a bounding box. Now, everything here is pretty much the same as you would have in the other one. Okay, here's my scenario. Now, in this particular one, I've added a couple of things. So I do want to show you about the humans. So right here, I have a human generation randomizer. let's take a look at the script. So the script that we have here is you can use age range from 0 to 100. I'm not sure how they judge that exactly, but we have height and weight and it's a 0 to 1 normalized ratio. So, 0.5 is not necessarily the middle because it's normalized, right? So just letting you know that you might need to play with that a little bit. You can put male, female, or neutral. Now this part always bothered me, but they have ethnicities, Caucasian, Asian, Latin American, African, and Middle Eastern. I always found that to be a little imprecise. Yeah, I won't go into that too much, but this was Unity's choice to use this language and have it set up this way. But you can select these and adjust them however you want. Okay, and what'll happen is Unity has a generator that will go through and create these humans and add them to your scene, and there'll be individual customized humans every time, different clothes, different things on them, all that stuff. Okay, so let's go back and take a look at it. All right, so if we go into our main camera, let's go ahead and play this so you can see kind of what we're talking about here, and then I'll break it down. Gonna take a little bit again, get started. And I'll probably stop about halfway through. Uh-oh. Oh, I didn't like that. Give me 1 second, folks. Nothing like a live demo crashing. It's Unity's fault. It's not my fault. So that hadn't happened before.
Makes it more interesting, I always think.
That's right. That's right. It'll just take a second to pop up, and then we'll try running it again. And if we continue to have problems with it, I'll kind of talk through it, and we'll move on to the next one. Okay. The next one I find is more interesting anyway, but it's important to at least try to do this. All right. And we're still on this one. Okay, let's go ahead and try it again. There we go. Okay, so you can see the people kind of in these 4 different spots. It's showing 5 people at a time. Now look how fast it's rendering them and putting out key points, bounding boxes. I mean, these are just people floating in space. But they could be, you could use them for any number of reasons. It's got to reload because it just went through 50 of them, so it's got to reload the next batch of 50. All right, awesome. Well, let's take a look at what we got here. So this is saved under solo 2. All right, so let's look at our people here. Let me see if I can make this bigger for people. All right, well, you can see the people in here, they're kind of in weird positions. They're just in random positions, which is purposeful, of course. You don't want people in the same positions. And looks like we got a bunch of different ethnicities, clothes. Everybody does have clothes, so that's a positive. Let's take a look at the segmentation. Segmentation is perfect. We didn't have to worry about somebody messing it up in one of those services that you can buy. All right, and let's take a look real quick at, let's do solo 2, and we'll convert it to Coco so you can see the, okay. Let's take a look here. Okay, so again, you have all of your images are in here, right? And then we have our instances.json. all of our images listed categories, but let's take a look at one of these. Okay, so now if you're used to looking at these, we have segmentations, and then we have bounding box data and the key points. Now these key points match 100% the Cocoa data set. So if you pull in Cocoa and then you just add this in, you got tons of extra images. And it even has the 98, the coordinate, and then the 0, 1, 2, right? So 0, I think, is not visible. 1 is visible but occluded, and I don't remember exactly what they are off the top of my head. 0 doesn't exist. 1 is, it's there but occluded, and 2, you can see it, I think. Yeah. So it'll tell you where those key points are, and those are completely accurate, 100%. You're not worried about a label or messing it up for you. So that's exciting. Okay. So that is real quick how kind of the human works on its own. Now, that's interesting. Great, I got humans, I can add them. But let me show you something that's way cooler. If Unity works with me here. Not sure what's going on here. It's chugging along. Trying to load this other scene. Sorry, folks. I'm not sure what's going on. Must be some kind of caching probably or something. Doesn't like this. All right, I'm just going to reload it quick. So again, what use is having 3D stuff going on if you can't use it in specific kinds of environments? And so there's a lot of work being done on home environments, right? Those are awesome. You also have factories that you could replicate in a digital twinning world. Sorry. I'm just going to kill this process real quick.
I do have a couple of questions in the tab if you want me to run through them.
Yep, let's go through them.
Yeah, so the first one is, so this is Unity's equivalent to Unreal MetaHumans.
That's a kind of. MetaHumans is for real-time mapping, if I'm not mistaken, correct?
I'm going to say, I'm not sure.
I'm not sure.
Hopefully
So I haven't used that very much, but so I don't know, to be honest, in the comparison.
Mm-hmm. All good. Second one, is this fitting with, and then they've posted a link to Cocoa Pose datasets docs on Ultralytics. It is in the Q&A tab, which you will be able to see. I can move on to the next one as well.
So it should match the exact format of any data set that uses Cocoa. Like it's a perfect one-to-one match. Mm-hmm. And so what you would do in your data set is you would munge the data, so you could dump your images into the same folder and then figure out a quick Python script to copy all of your stuff from your instances.json and your new stuff into the existing one. That could work. Or you could just have it, read from both directories. That could work as well.
Happy days. Just got a couple more.
Yep.
Could this be used to build your own pose estimation library from training from this and then using this with Cocoa? Yeah,
so the only challenge is that the synthetic humans data set is licensed for academic and research use only at this time. But you can talk to Unity about that. And I'm sure you could work something out with them if you wanted to do that. We've had some conversations with them in the past about various things at BestieBot, and they've been very open to talking with us. And so, I mean, just especially even the licensing itself, right? So you know that Unity, you just pay a flat fee versus Unreal, which, you know, you got to give them a certain percentage of your company and everything you make, basically to do anything with their systems. Unity is much better for smaller indie kind of projects and groups and things that are going on. And so they would work with you on that. And I would say that, yes, this is a great way to do it because you know that a lot of the pose detection models are all non-commercial use. It's very hard to find good data if you're trying to use commercial data or to use this commercially. So, yeah, I mean, you could probably reach out to Unity and talk to them about that.
Perfect. Next one, how would you compare Omniverse and Unity's abilities as of today?
Yeah, so you know, it's funny. I just got off the phone with the Omniverse team 10 days ago, less than 10 days ago, because for various reasons, things that we're doing at BestieBot, and we had a lot hours of conversation about this because I really wanted to use NVIDIA's Omniverse stuff. It is really hard to figure out. It really is. And even NVIDIA will mention that. But what Omniverse has is that you can do anything you want with it. That's also the challenge. So like, for instance, here in Unity, I have an inspector and a hierarchy and a console project. And a lot of these things are tied together already in an IDE for me to use. If I wanted to create that with Omniverse, something like this, I would have to build this UI first. And then I could go in and do these other things. And so anything you want to do, you got to build more from scratch with the Omniverse. It does give you flexibility. You can heavily optimize it. And there's definitely some really cool tools and integrations with NVIDIA's stuff. But just be prepared that it's going to take twice as much work to get anything done. That is all done in Python, though, or C++. So if that's your background, you know, it may be worth looking into for you.
Perfect. And then there's one more, pose features, meaning do they match with the feature data sets where the body post is?
Feature data sets. So where the body posts are, I'm thinking, oh, yes. Yeah, the poses. So 0 to 17, yes, they match perfectly. So yeah, because what happens, right, in your let's take a look at the data set here. That's a good question. So when we look at the segmentation here and you have key points, is this the right one? No, that's not the right one. Let's get one with good key points here. Yeah, let's look at the key points in this one. Right? All it is an array of 3 values. So you're like, okay, well, I hope that array, you know, item 3 matches, you know, the nose, you know, XY coordinate. It does match. Everything matches. And I used, it's right here. This is very similar. These are skeleton connections, but it's like, you can get the list of the actual items from their setup on the Cocoa data set, and they do match. So I won't go into it too much more, but yeah.
Perfect. We've just had one final one come in, and then we can move on until the next break. But what are the metrics commonly used to benchmark pose estimation performance on Cocoa?
That's a good question. So I think it's the MAP. I want to say, let's see here. What did they use? AP. So just how close they are to each other. My guess is I don't know exactly. So anything that I say is going to kind of be just guessing, but I'm sure it's some kind of like mean squared error to a point. So like if the knee is off by like, you know, a couple of pixels, that'll be an error, a smaller area than if it's off by like 10 pixels. That would be my guess, but I don't know. Sorry.
Good. Perfect.
Cool.
Yep.
All right.
No.
Let me keep going. So let me show you this last part here. Okay, so this is just a generic room that was created, and let me explain how this works a little bit. So this is full of items. We got floor, walls, etc., etc. If you're not used to the 3D world at all, let me explain how this works. So you generally have, let's see, let's move this over. I think it's the sofa. Let's look at this sofa. So you have, it's made up of different items, right? So I have one cube, which is in the back. It's been shrunk a little bit. I have another cube, and another cube. And they just came together and they're a 3D object. And so then we put this title here. This is sort of like it's like a null reference is what it's called in the 3D world, but it's a Markov blanket, whatever. It's like an identifier. You know, it's a DOM element if you're coming from the web world, right? So it's like a div tag wrapped around these objects to create some kind of semantic meaning. So this is a sofa, right? And you can do things with this. And so in this particular instance, let's actually come back and take a look at this. We had to do a couple of things. So we want to place people in this room, around the room. We want to have them sitting on things. We want to have them moving around the room. This could just as easily be your studio for a musician, or, you know, for a music video, if you're doing that, or for whatever reason, a factory setting. Like it could be any number of things, an office, whatever. In the 3D world, you gotta have to kind of show where items can go. And you got to bake them in a place. So it's like pre-compiling the scene. So you pre-compile the scene to have where people can go. So let me show you what that means. So on the floor, we have this mesh here. You can probably see it. It's this little blue thing. And where it's gray, they can't go. But where it's blue, they can go. All right. And that's the nav mesh. Right? So area type, it is walkable. And we can set up other areas for not walkable, et cetera, et cetera. In fact, we have these area settings that I've identified in here. There's a walkable, not walkable, jump, and sitting. And so we identified these. And the only places that they can sit are on the couches and on these chairs. So we went to the sofa. And on the sofa, we don't want them sitting on the back of it or on the sides of it. So we put this little thing on here. It's a nav mesh modifier, which allows us to say anybody can sit on this in this particular area. So they can sit on it here. And again, we added that to the stools as well. Let's see here. There you go, at the top of the stools. So they don't sit on the bottom. They sit on the top, and we added that mesh modifier. The cool things are, you know, you can add a lot of things to this, like colliders and other things in the 3D world to make this very responsive to the things that you put in here. NVIDIA, in their terms, somebody mentioned the Omniverse. Well, they have this Isaac Sim, which can simulate these kind of physics engines in like animations. Now, you can't do that necessarily with this, but I'm sure it'll get there. So, okay, let's just take a look at it real quick in our scenario. So we've added a nav mesh placement randomizer. So it'll add people to different parts of the nav mesh that were walkable or sittable. And we have a pool of 50 people. We're only going to put 5 people in a scene at a time. All right. And what are we going to print out here? This is one where we're going to do depth. Okay. So we're going to do all the normal stuff, key points, bounding box, et cetera, but we're also going to do depth. And I'll show you why in a second. Oops. Do here, align to selected. Yeah. Okay. All right. So let's go ahead and run this real quick, and you'll see people start to populate on here. Now check to see where they're sitting and where they're walking around. It'll stop in the middle, and then it'll pick up again as it goes through its second set. Gotta pause real quick. Now, the cool thing is when you're making this data, you can place the camera anywhere. Like if you're in a factory and you know a camera is going to be somewhere and you need a digital twin and you want to make sure that it gets people accurately and at the right angles, you can do all that stuff in the 3D world and just generate it. And then you can be guaranteed that you're picking up people at the right angles. All right, so let's take a look at what we got on this. Are we on our main camera here? Yes. So let's show the folders. Should be solo 3. Yep. Okay. Let's do our conversion real quick so we can look at it. Okay. Now it just uses RGB for here, but the interesting thing that I like in here is because we added a depth labeler, we have a depth file, which comes in. Let's take a look at the PNG so you can see that first. Here's the PNG. All right. I don't like that one. Let's look at a different one here. For some reason it's a little blurry here. Not sure why that is. That shouldn't be like that. I haven't seen that before. But see if we can find one that is not. No, there's a person up here. You'll see that. They're a little blurry. That might have happened with the render. So that's why you usually want to do like 100 at a time before you make sure that it's accurate. And then you can do 10,000 on your runs, just like you would normally do on your setup. So let's look at this depth map first. Because these depth maps are created as 32-bit EXR files. And so that means that if you open it up, you're just going to see a bunch of red. Let's just dump it in here and see what we get. Oh, it's a good thing I saved it. All right, let's just look at the file. So real quick, this will be the last thing we look at. So here's the room. Now it looks like just a red file. Well, that's because it's in 32-bit, and normally you're only used to seeing 16-bit. So if we look at this, all the color information is here between 1 and 2 in the setup. So if we adjust the exposure so that that's more in the middle, now there it is. See how you can start to see the people in the background here? Like you can actually see the depth map. The problem is not that it's unreadable. It's just that it's so precise in its depth estimate that you have challenges sometimes seeing it with the pixel value. So you can renormalize this for uint 8 or float 32 or float 16, where you can really see the images a little bit better and just kind of average them out and stuff like that. Like that, there is some post-processing that you'll do, but it's very, very precise for your camera. So it's very good when you're doing any kind of pre-processing on your depth data. So you need to make sure that you are exactly 1.57 meters away from something in your estimate of for your computer vision model. It's really, really good. So I just wanted to show you that the EXR files. So I know we're out of time, but that's essentially what Unity has for these setups. Again, if you want to use this in your computer vision products, make sure that you talk to Unity about anything you use with synthetic humans. Perception, I believe, has a different kind of license. You can go check that out online. But these are fantastic tools. I would definitely learn some stuff about 3D work if you're going into AI and you're interested in Python, simulated agents, LLMs, anything like that. A lot of this stuff is going to become very relevant over the next couple of years. So with that, thank you very much. And Jordan, thank you very much for having me out, and to your team at Amicus. And I appreciate it a lot. And I can answer any questions that people have.
Yeah, no worries at all. Thank you so much for the demo. Yeah, it was a great demo. I went over my head a little bit. I'm not overly technical, but I'm sure it was very insightful. And I think from all the questions, people enjoyed. So we do have just one final question in the Q&A tab. What machine learning packages work well for training pose estimation models from Cocoa data in Unity?
I use PyTorch for everything these days. I made that switch a long time ago. And I believe that there might be some models. I can't remember off the top of my head, but I believe there are some models that you can use there as a pre-trained model to try to do that. The interesting thing about key point detection is to do it accurately, you have two choices. You can either do it all in one shot, or you can do a two-stage. So in the two-stage, you do a normal CNN, right, where you do people detection and object detection, and then you pass that to a key point detector. And that's a little bit slower, but sometimes more accurate. But there's definitely two stages, so you can look that up. And then there's what are known as single shot. And the new YOLO, after version 7, has a key point detector. So YOLO 7 does have that built in, and you could augment that, I think, with PyTorch. And that's all in one shot. That's a one-shot key point detector. And you could probably add the data through there. As far as, anything else, you probably have to do a little bit more research about, how to do that.
Perfect. Happy days. Very insightful. Much appreciated was the response to that answer. So happy days. So again, thank you for the demo, Richard. Really appreciate you taking the time for putting that together and then setting time aside to actually present and give that demo. So really appreciate it. I know you potentially got a few other topics in mind around large language models and some other things. So yeah, if you are interested in returning, would be honoured to have you back. As well, thank you to everyone who attended this evening and participate with questions. I'm sure if you've got further questions, I don't want to set you up here, Richard, but I'm sure you'd be happy to discuss offline after the show. And also, if you enjoyed today's event, do keep an eye and follow the Amicus Recruitment and the Live Series LinkedIn page for updates on future events. They do typically happen on a monthly basis, whether that's across machine learning, Python, or if you're interested in Golang, Rust, or JavaScript, there'll be events happening on a monthly basis within those areas as well. So, but again, thank you so much, Richard. Really appreciate it. And I look forward to welcoming you back next time.
Awesome. Thank you, everybody. Have a great night.
Have a great evening. Bye.